All right, so we're going to solve quadratic equations by graphing. And there's new vocab, I guess. I don't know if it's like super new. But right over there they say quadratic equation. So how do you know if something's a quadratic equation? Right here. How do you know if something's a quadratic equation? Because that's a what? What makes something a quadratic equation? Can't be anything, it just has to be something specific.
Exponent.
What about the exponent? Has to be what?
Squared.
Has to be squared. So the quadratic equation, right, is an equation with an x squared term in it. If there's no x squared term in it, it's not a quadratic equation. Okay? Standard form of a quadratic equation we've dealt with actually before. Okay? And so then that's over here, right? Ax squared plus bx plus c equals 0. Right? A, B, and C. Those are going to be our friends. Okay? All right, so that's the two definitions. We should kind of know them. And it's then this paragraph here, because the idea is like everything that you guys need is in this book, basically, right? Okay, that's the idea. Like, I don't even need to be here, really. I don't even, But it says one method for finding roots. Oh, that's the other thing we got to talk about real quick before we go on. Because they're going to start talking about these terms that they didn't define for us. So one thing that you got to make sure you know are that solutions to a quadratic equation are the same thing as zeros, which is the same thing as x-intercepts. Okay, so those words can be used interchangeably. All right, so if I say 0, you need to think of x-intercepts. Now, the reason they're called zeros is because we have an x and a y coordinate plane, right? And so what we're saying is, well, when y, let me show it for you. Right, so what we're saying here is this 0 up here, right here, is actually the y value is 0. And so then you set this thing up and you say, well, when y is 0, what are my x values? Okay? And that's why they're called zeros, when y is 0. And then that's why when you graph them, you get x-intercepts, because the y value is 0 there. Is that okay? All right? So again, in this paragraph, they start talking about things like, hey, by the way, there's a bunch of ways to solve it. This is just the first way that we're going to talk about it. Now, this is the least efficient way. Because just like anything else you graph, you can't really get super, super exact. So usually, you don't really do this method. You would do this method for something like estimating the solutions. Okay, well, this is what we're going to start with. All right. There's 3 other ways that you can solve them. One is by factoring, and I understand that you guys are not factorers, which makes me sad. So we're going to remedy that here soon. Okay. So then we do it by factoring. We do it by something called completing the square, and then something called quadratic formula. All right, so we're going to spend some time solving quadratics, because again, they're super useful. And I keep threatening you guys, and I'm going to show you a video of someone punting a ball and going up, and it does a problem. We can talk about stuff. All right, so I'm going to try to remember that tomorrow to do, because it's a good video. Okay. All right, so again, usually if we're trying to get an exact solution or an exact 0, we're not going to graph, but that's what we're going to start with. Is that okay? All right, so we're down here at example 1. All right, one real solution. All right, so it says here, solve this by graphing. Your first step for pretty much any quadratic, anytime you're asked to solve it by any method, your first step should be rearrange the terms so that one side of the equation is 0. This is always going to be your first step. All right. So then, how do we solve that or get all the terms on one side? What should we do? Right. So right now it looks like this, right? 10 excuse me, minus x squared. I think that's an equal sign. 4x, what was that, 14?
Yeah.
All right, so I want everything on one side. What should we do?
The other side.
Yeah, so all we're doing is subtracting or adding to the other side. So personally, I would rather not have a negative x squared. So let's move everything over to the right-hand side. So if we're going to do that, what happens? What should we do? All right, so we're going to add x squared. So we have 10 equals x squared plus 4x plus 14. Well, I want everything on, let's go everything to the right. So let's not subtract 14, let's do 10 instead. Okay, make sure you guys are combining like terms. So now I have 0 equals x squared plus 4x plus 4. No matter what, you're going to do that first step for the next, like, I don't know, however long we're in this chapter, basically. That's what you got to do. Right? That's going to be your first step. So back to your notes. Was that good enough? Did we see that? Are you happy? Some of you guys must have, like, photographic memory. Is that okay? All right, so for graphing, like what they want you to do is start with this little thing. We've been talking about this for a little bit. Negative x equals negative b over 2a. What the heck is that thing? What does it do? What is it? It's not slope.
Oh, what thing? What was that?
Negative b over 2a. What does that do for us?
Slope. Or,
Not slope.
Or the x is second or whatever.
Well, this what does this do for us right there? We've seen that one before. It's three words, rhymes with axis of symmetry. Axis of symmetry, yeah, it gives you the axis of symmetry. So we're going to start with that for this. Okay? So I always do negative b, but like they keep the negative out front, whatever, man, it'll work. All right? Oh, where did didn't I put 4 and 4 there? Why did it go away? Didn't I do this?
Yeah, I did. Yeah.
Why is it not there? Oh, you can't see that green. Joe, you got to say something, man. Can you see that green, Joe?
Not really.
Oh. How about that?
Yeah.
Is that better? Sorry about that. Apologize, Joe, man. I'm sorry. All right, so for those of you playing along, I would go to y equals, right? Go to y equals and put this thing in right here. Because this is way easier. Otherwise, you're plugging in a bunch of numbers, which is totally cool. I mean, that's what I do on my off time too. But, you guys live in technology, right? Like, you don't even have to change the channel on your TV anymore. You don't even have to press a button as far as I know. I think you just tell whatever voice command, right? But I think, yeah, right? You can get a TV, right? Find sports for me. Yeah.
Yeah, I gotta do Sam.
Yeah.
Do what?
Yeah, some of them do. Yeah, right, that's what I'm saying.
It's a remote.
Yeah. Yeah, some of it does that.
I don't think I've touched a remote like once.
Yeah, right.
That's lazy.
That's what I'm saying.
Lazy.
We used to have to get up and turn the channel.
Yeah, the children.
That's why people had children, correct.
Yeah.
Like, it's like, I'm done getting up off this couch to change it to the third channel that I have.
Time to go change the channel.
That's true. That's what I was born for.
Go turn it up.
Yeah.
Go hold the antenna.
That's why my middle name is Remote. That's why they named me.
Go hold the antenna.
Brian Remote Eversold. I never understood it. Because there was no remotes before. Like, my parents created the word. So you're welcome from my family to yours. Yeah. Just like everything else in this country, it was built on the backs of young labor. Child labor. That's how we did it. Yeah. Right? When I was first born, they used me as a shovel. In my face, and they'd just like shovel things up when they needed it off. That's what the kids used to do. So you guys got it so much easier now. You think it's funny? Why do you think I keep everything covered up? You don't want to see what happened. It was bad. All right. What, so did we find the axis symmetry yet? No, not yet. I got caught up with things. All right, so then, right, we plug in negative b, so then our equation is, right, negative b, so negative 4 over 2 times 1. So what's negative 4 over 2 times 1? Negative 2. And so what do we know about this point right here?
That's 0.
No, we don't know that. It ends up being a 0, but we don't know that it's a 0. So what happens at the axis of symmetry?
It's both sides are the same.
Yeah, and so then it comes straight out of the vertex. Comes out of the vertex. So we know the vertex is going to be right there. Is that okay? All right, so then someone have this in y equals and got a table for me? All right, what do you got? So we're starting at negative 4. You're going to tell me up to 0? 4. 1.
0. 1. 4.
All right, and so then like Joe just said, right, everything's symmetric, right? 4 and 4, 1 and 1. And then they graphed it for you, yeah? Okay, so again, if we're looking for the solution, that means we're looking for the x-intercept, or we call them the zeros. Okay, so then this coordinate right here is the only place it touches the x-axis at negative 2, 0. So this one has one solution. The 0 of this function, the solution of the function, right? The x-intercept of the function is negative 2. Therefore, the solution of the equation is negative 2. Or I can even write it in your favorite set builder notation, x such that x equals negative 2. How's that? All right, so I told you that we were going to get away from doing the checks online because we can just do the checks right now. Let's do a check right there. Right, you got some notes, right? Get started on that. What's your first step you should do though?
Get 0 on one side.
Yeah, get everything on one side. Get everything on one side. Yeah, personally, I don't like having negative x squared, so I would move everything to the left. That's what I would do. But you're your own person. I can't tell you what to do. You can rebel against me. Do it your own way. I think that's what you get, you know. Is that what you got?
Would you combine x to the second and negative 31x?
No, anything crazy. Those are not like terms. Don't do that.
So you just put it in.
That's what I got. Does that look pretty good to you? Again, I'd have this thing. The first thing I would do now is put it in your calculator, unless you like totally want to be plugging in things. What's the next step? Oh, yeah. Okay, yeah. What's the step out of that? Well, okay. So I want you to do it like what they're trying to get you to do. So what was the next step? What we did before? Yeah, find the axis of symmetry. Okay. So you want to know this thing. That's going to be your friend At least it was my friend when I was growing up. The nice thing about imagination is you can have as many friends as you want. Right? And they're more real than those friends you have on Face Smack or whatever it is you guys do now. You guys do Face Smack? Or you guys are Insta Smack? Or what's the other one? Photo something. Oh, I know you guys do that, yeah. No, what's the other one? Snapdragon? No, I did that one already. Whatever it is, yeah. It's like how can we make everyone into a total jerk? Oh yeah, let's just get them online social media and then everyone will turn into this horrible person.
It works.
And it'll work. Yeah, it worked. It totally worked. Because like now, everyone is a horrible person because like they're on this ridiculous thing. We got 12. I think that sounds good. 24, because it should be 24 over 2 times 1. So 12. Okay, so now this is our axis of symmetry. And if you notice what they did on the other problem, they started at the axis of symmetry and then went 1 in each direction and then 2 in each direction. So that's what I would suggest you do. We're going to make ourselves a little XY chart here. And then I'm going to start at 12 here, but then I'm going to go, right, like 11 and 10, and then 13 and 14, right, axis of symmetry right here. That's going to be our vertex. All right, so when we start plugging these in, 12 is 0, okay.
13 is 1. 11 is 1.
Okay.
14 is 4.
And then probably 10 is 4 then also, right? All right, so we are solving this by graphing, so we should probably graph it, right? So then, right, it looks like this. I'm not going to get super, it's hard for me to get super accurate on this. I got graph paper up here for you guys. But it's going to look something like that. Is that okay?
Yeah.
All right. And so then, what is the solution to this equation? X equals 12. That's the solution. Now, how do you know that's the solution? No, that's not why. What? Because that's where y is 0. Okay, so it's very important to keep that straight. Okay, so it's not always going to be right there. We're just starting with it right there. Okay. So again, it's 12 because that's the y value of 0. That gave us a y value of 0. Good enough? All right. How are we feeling? We feeling good? I feel pretty good.
I don't.
Sorry.
Yeah.
Yeah. No one cares about you. You're forced to care about mine. Yeah. Go for it. All right, so here's example 2. This is all we're going to probably have time to get through, and then you're going to have 1 to 14 on page 157. All right, we'll finish up tomorrow. All right, so it says use a quadratic equation to find 2 real numbers with a sum of 24. What the heck is sum? Equal when you do what? And so it's equal when you, so we can actually start with something. If we have, right, 2 real numbers that add up to 24, give me something I can write, like an equation I can write. No, don't tell me the answer. You don't know that that's the answer. So, like, give me, like, how can we write? How about let's do x plus y, because we don't know that they're the same. Okay, so let's say that it's like x plus y equals 24. Okay? And then they go on and say a product, they have a product of 143. What's product mean? Multiply. So So x plus y equals 24, and then x times y would be 143. Okay?
Easy, right?
All right, so now they're saying, hey, look, let's let x be the one that we're looking for. Let x be one of the numbers. So then what would y be? If x is, like, up in this, right, we're like, x plus y equals 24. So, like, if x is the one we want, what would y equal? No, don't try to answer. Like, so the whole point of math is that you don't have to figure out the, like, you just do the steps and it gives you the answer. Say it again. Yeah, so, well, okay, so otherwise, yeah, so we're going to subtract x basically, right? So then y equals, sorry, Joe. Yeah, y equals, right, subtract x over 24 minus x. Oops. Okay, so let x be one of the numbers, then 24 minus x will represent the other number. So then we've already done, so then what happens now, right, is you take this information and substitute it in right here. Because that's what we're saying, y equals that. So, like, let's not do y. You don't want more than one variable. That's more work. One variable's kind of easy, right? So we take that and put it in here. So then that's why x is still x. Y became 24 minus x. And so now that equals 143. Is that okay? We okay so far? And now we got to solve this equation. So you had to get it into standard form, which means distribute anything that you have, get it all on one side of the equation. All right, so then, right, we're starting here, right, that's what we had here, right, so right here. And then they say distribute. So, right, so we're saying x times 24, x times negative x. Is that okay where that came from? All right. Then they're saying, like, why is that happening? Bring that back. I don't know, who cares? Right? So, like, they're just kind of like what I was saying, like, I don't want a negative if I can get away with it. So then they added the x squared over here, subtracted the 24 over here, and now we have, right, the standard form of a quadratic equation. Fair enough? All right. So now here's your favorite formula so far, axis of symmetry. So what's A, B, and C here? What's A, B, and C?
A is x is second.
Well, I don't want the x, I want just the coefficients. So A is what? 1. B is negative 24, watch your signs. And then C is 143, okay? So then we're going to do the axis of symmetry, negative B over 2A, right? They got negative 24, negative 24 over 2. And so what does that give us? 12. Yeah. All right. If you remember Joe's second step, you already put that in your calculator. X and the y equals x squared minus 24x plus 143. Why does that disappear when I move? It's not supposed to. Go back. So again, this one is our vertex. All right, so we got that in. The y equals, going to our table. Again, notice that while you guys are getting in your table, notice that they start right in the middle and then they go 1, 2 up and 1, 2 down, okay? All right, that's all they're asking you to do. Find the vertex and get a couple points. So what's this what are these values? What are these values? Barely wait. Could be anything really. It can't be anything. There's specific numbers. You can hand do it. You can hand do it. I won't take that enjoyment away from you. What could it possibly be? What's 14? 3? I'll take your word for it. Oops. 3. What's 13? What's 12? What's 11? And 10? Alright, so then we got a point here. Right, we got 14 and 3, we got a point here. And we got a point here. And if we sketch it, you can see, well, I kind of get it pretty close. However it looks. All right, so what are the zeros? 11 and 13, because that's where the y value is 0. So our 11 and 13, okay? So one of those numbers is 13, one of them is 11, and so then that's what your solution is. How's that? All right, is that right? All right, so now you got to do your check. There's your check. So, right, that should be the equation that you get before you change it to standard form. Is that okay? Yeah, probably. I think that's right. Don't be a hater. I think haters are gonna hate if I understand the equation. Okay. I believe haters are gonna hate, and I think players are gonna play. I keep those straight.
What's up?
Sometimes players are going to hate and haters are going to play, but I think usually
Right.
it goes haters are going to hate. So again, I'm not a big fan of negatives, so I'm going to go this way. I try to be positive, if you know what I'm talking about, man. She does not. Does not know. Try to be positive all the time. Like, you know, I really like your jacket.
Oh.
I don't think he cares. I don't think he cares. He's uninterested in what I'm saying. So that's where I'm at. I got standard form. Now I'm going for my axis of symmetry. Quentin was disgusted because it was a decimal. Completely just grossed out.
21.5.
Yeah, 21.5. God, who wants that, man? Nobody.
Not the table.
I love decimals.
Oh, very positive. I like that you're positive. Yes.
Facts.
I know why you're not.
Normally he's not. So he's on.
He always complains. Have you not heard him?
I usually don't listen to anything you guys say. It's like a rule I have. It's like on my mirror at home. I can get up, shave when I shave. It's like, who wants to shave? And it says, be your best today. Don't listen to anybody in your Algebra 2 classes. And then be nice. Those are my three.
Be nice. Yeah,
Be nice. Anyway, so what do we do with that?
Make a table.
All right, let's make a table.
Start out with negative 21.
Yeah, start out with negative 21.5. Just like Quentin, I don't want to do the decimals. In fact, you got to make your calculator do the decimals for you. So, what happens when we plug in negative 21.5? Does anyone know how to do that? Is anyone special enough to do that? What'd you get? Yeah, just plug it in X.
For both X's or just the...
Oh yeah, so because you're evaluating a function still, right? We're still doing this. So then it'd be like, watch your parentheses, 21.5 squared plus 43 times negative 21.5 plus 306. So what's that get you? Yeah. Should have some. Could be anything. What'd you get?
Negative 640.
Negative 640? Okay, it's way up there. Okay, we don't really need it. All right, so then, like, the problem with this one, which I think is kind of weird that they put it on here. Oh, that's not right. Never mind. Forget it.
Negative 3.
Negative what?
Negative 3,
Negative 3?
I think. Oh, wait.
Isn't this like how you can mention the second table set?
That's not.
Yeah, so you can go to the second table set, and then you typed it in, what'd you get?
I got negative 156.3.
156.3. Now, that's not doing this. Like, that's so far up when we try to graph that. Then if you go one off, you're probably not going to get down to the x-axis by going one off.
Mine all say that. 156.3. Every number says that.
Well, you missed an X then. You probably didn't put in your X's right into Y equals. So now the problem with going there though is now to get the integers you gotta, like, cause you don't know, you can't just sit there and type in numbers and figure it out. So you go back to the normal table. And then basically what you're gonna do is go up and down until you see the Y value is 0. Because like, I don't know like how you're gonna get there otherwise. I mean, there'd be a lot of very technical graphing and stuff. So we can find 2 zeros here though.
I got the Y value is zero.
Negative 9, is that what you said?
Yeah.
So negative 9, 0. Negative 34. Okay, so those are our two solutions. Okay, so then it's easy to check to make sure you're right. You know, like, because what's negative 9 times negative 34? Well, I imagine it's 306.
Yeah.
Okay, and then is negative 9 plus negative 34 negative 43? Okay, so, you know, you kind of are limited on when you're doing it just all by hand, like, you know, finding that by graphing without a chart to go through, I mean, would be annoying, which is why usually you don't solve these by graphing to begin with, but that's kind of the idea. All right, so is that okay with everyone? All right, so then all you got to do is 1 to 14. They're all the same problems we just talked about. Tomorrow we'll finish this thing off. Again, this is the last thing that shows up on the midterm.